Welcome back. In this video, we're going to use our knowledge of enthalpy of a reaction to find out the specific amount of energy that's absorbed or released if given a specific amount of products or reactants. So we're combining our knowledge of stoichiometry with our thermochemical knowledge to have a more specific type of reaction to where we know not just what is reacting, but how much energy is required. So let's have an example. If I combine nitrogen gas and oxygen gas to form nitrogen monoxide gas, it requires 181 kilojoules of energy to be sucked out of the environment and stored in the bonds of the nitrogen monoxide. So this is an endothermic reaction. And if I know this basic equation of 1 mole of nitrogen, 1 mole of oxygen yields 2 moles of nitrogen oxide, I can take any specific amount of any of these and find out how much energy was used or absorbed or released. So in this case, I'm asked to find out how much energy is absorbed when 1.65 grams of the nitrogen monoxide is produced. So we know that the 181 joules is stored in the bonds, so it's absorbed. So we can actually consider this 181 kilojoules as one of the reactants of the equation. So I can rewrite this as nitrogen gas plus oxygen gas yields plus 181 kilojoules of energy yields 2 moles of nitrogen monoxide gas. So if I rewrite this, I can now basically get a conversion factor here, because I know that for every 2 moles of nitrogen monoxide gas produced, it requires 181 kilojoules of energy. So those two things will always be equal to each other. No matter how much of the nitrogen monoxide is produced, that ratio of 2 to 181 will remain the same. It'll remain constant. So I'm going to use that in our favor to try to figure out this problem. So if we have 1.65 grams of nitrogen monoxide produced, how many moles? Because remember, this is a molar relationship that we're going to look at. So really, all you need to do is put grams into moles, go through the periodic table to find moles, and then use this conversion factor to solve the problem. Okay, so we've got 1.65 grams of nitrogen monoxide, and through the periodic table I found out that that's 30.1 grams of nitrogen monoxide, and when I cancel everything out, I've got 0.055 moles of nitrogen monoxide. Okay, now that I have the nitrogen monoxide, I can use that in my conversion. So we've got 2 moles, this is from the balanced equation, 2 moles of nitrogen monoxide produced for every 181 kilojoules absorbed. So if I put my 0.055 moles and then cross multiply, so I'm going to multiply 0.055 times 181, divide by 2, I get 4.98 kilojoules absorbed. So I used what I knew generically to find out something very specific. So I hope this helps you. Watch it as many times as you need to and ask me in class.